In previous part 1, we decomposed the data set, seasonal decomposed the data set from here by reading the data from Kaggle notebook, then decomposing it. We got these residuals, seasonalities and trends. Then after that, we checked the autocorrelation by using this on adjusted close price. We used autocorrelation. So here the autocorrelation is 0.99, means it is very highly autocorrelated. The adjusted close price is very highly autocorrelated. Highly autocorrelated means if suppose in historical data set we checked a pattern using this autocorrelation formula, which is at the back end in Python. Suppose it is following some pattern, like if previous day price is very high, then it is likelihood that today's adjusted close price will also be high. So it is somewhat like that prediction. It is a formula. Let's say suppose here we have used lag equal to 1. Lag equal to 1. Lag equal to 1 means if it previous one day before the price was somewhat, suppose we have temperatures on day 1 the temperature is 25, day 2 26, day 3 27. So each day the temperature is rising by 1 degree Celsius. So this formula will automatically give high correlation because each day it is rising by 1 degree Celsius. So that means it is highly autocorrelated. If the data would have been somewhat like this, like temperature is 13 degrees Celsius, then 26, then 11, then 30 day wise, it is not possible, but let's say assume it. If it would have been like this, then it would not have been highly autocorrelated. If it is following some pattern of rise and decline, some ratio it is increasing or decreasing constantly in a consistent format, the data points in the time series, then it is highly autocorrelated. So in simple words, if it has a high autocorrelation nearer to 1, greater than 90 or greater than 80, or let's say even greater than 70, then we can predict or predict the future stock price value on the basis of historical stock price value. This is autocorrelation tells us, but we will not predict using this autocorrelation. It is only an indication to check. We will predict it using the ARMA model, auto regression and moving average model. Like regression is between the two variables, but auto regression is a, the regression on the single variable on itself. It is auto regression, like predicting the future stock price on seeing the single variable at adjusted close stock price only on single variable. But in regression we used two variables. If one is rising, then another must also rise. If it is a highly correlated, not autocorrelated, correlated. So that's the case here. So auto regression, we will even verify it using a visualization. We will import pandas.plotting lag plot. We plotted this lag plot like this. We given time series and lag equal to 1 we provided. So it is saying, suppose we have 500 here. 500 is the current. We are on the this point 500. So 500 is here. So let's suppose one day after it is, let's say 600. Let's say, so it is somewhat above 500. So it is telling on the current time and one day ahead of the time. It is comparing the plot it is creating. Like suppose day one is 0, day 2, day 3. Then it will be, like suppose it is day 1, day 2, day 3. Then it will be day 1 with day 2, and then day 2 with day 3. Then day 4 with day 5. One day ahead we have shifted the data frame. So it tells the correlation between those, whether they are scatter plot between those. So see, we can see it is a very narrow line and very straight line. So this also indicates that it is very highly autocorrelated. So when the final most visualization, which is very powerful and tells everything in a single go, we will use that in here. Let's import for that from stats models dot dot graphics dot tsa plots import plot autocorrelation function ACF. It is imported now. We will also import partial autocorrelation function with it. We simply write a P here. So both are imported now. So I will tell here that partial autocorrelation is somewhat like this. In autocorrelation, suppose we have lag of here, the lag is 1. In this visualization, lag is 1, C1 plus 1. If I would have changed here lag as 4, then also it is highly autocorrelated, and now it is here 4. That is current time and the 4 days ahead time. We are checking the correlation, autocorrelation. So if the lag is 4, so in autocorrelation, if we check the 4 days ahead or 4 days before, then the days in between, the day 3, day 2 also has some effect on the prediction. But in partial autocorrelation, we directly check between day 4, day 1, day 4, day 8, day 12, and in between the day 2, day 3, day 5, day 6, these will not count in the effect. We directly jump to the 4 steps ahead and we check the autocorrelation, partial autocorrelation. But in autocorrelation, each data point, each timestamp will have effect if it is present in data in a consistent format. Now we will see our autocorrelation function plot and partial autocorrelation function plot. We will write plot ACF. We will write here DF to our time series, and we will check here lags. We want to check for, let's suppose we want to check for 30 lags. Let's check for 30 lags. 30. See, all have near to 1. See, it is slightly decreasing from 1, but all has approximately near to 1 autocorrelation till the, what is happening here? It is not lag, it is, I think, lags. Yes, now it is correct plot. Now no error is there. It is having 1 1 1, near to 1 autocorrelation. See, autocorrelation at 0 will always be 1 because it is the correlation to itself variable. But at 1 it will change. It will drop from 1, decrease from 1. So these are highly significant. This area tells that beyond this area will be highly significant for this model. Till 30 it is predicted, very much predictable. Same plot we have here. So plot PACF will check partial autocorrelation function DF2, comma lag we will check here for 30. In partial autocorrelation, it is not highly correlated. Not highly correlated in partial autocorrelation. So I think somewhat again we have done the same error. See, now the correlations are falling. So we see here that at after 1 it has decreased. So one rule of thumb is there. If autocorrelation is gradually decreasing and partial autocorrelation has dropped after 1 degree, then we will use a AR model of degree 1 and MA model of degree 0, ARMA model of 1 degree, 0 degree. 1 degree for AR and 0 degree for MA. If you have knowledge in this domain, then you will understand it. Autoregression ARMA model for prediction using a single variable. So we will use here, according to the visualization indication, we will use here AR auto regression model of degree 1. In next video I will show you how to predict it using this model. In part 3 I will show you.